What is happening, Algebra 2? Grab your Unit 5 reviews. Starting with number 1. The first thing you should see is this radical sign on the bottom, and in order to get rid of that, we need to multiply by the conjugate. So if you notice, since we have a minus sign here, my conjugate would be 3 plus root 3 instead of 3 minus root 3. So now if you multiply those together, you're just going to distribute. So the 2 times the 3 is going to give us a 6 plus 2 root 3 on top. And then for the bottom portion, if you have 3 times 3 and 3 times root 3, we're going to have 9 plus 3 root 3, but you also have to distribute the other two terms, the negative root 3 times 3 and the negative root 3 and 3, and that would give us a minus 3 root 3. So if you notice, these terms in the middle are going to cancel out, and at the very end you have a minus root 9, which we know root 9 is just the same thing as 3. So my bottom portion is all going to simplify. These cross out, and then this is just a minus 3, so 9 minus 3, the whole bottom would turn out to be 6. So if we rewrite it, we have 6 plus 2 root 3 over 6, and we can simplify it by dividing everything by 2. So we've got 3, and this turns into a 1, so my final answer would be 3 plus root 3 over 3. Now for number 2, we have different radicands, so we're not going to be able to add and subtract those until we make them the same. So we need to break down each of these numbers inside to see how we can make those the same. So let's go ahead and make our factor trees for each of those 3. So if you look at each of our trees, 98 gets broken down into 2, 7, and 7. 108 breaks down into all these. And 288, if you notice a pair is going to break down like your 12 and 12 there, you don't have to break all those down. So we can just rewrite them like such. We'd have 5. And then 98 would be 2 times 7 times 7. And then your 108, you'd have your root 2 times 2 times 3 times 3 times 3. And then your very last one, your 288, is going to be 2 times 12 times 12. And if we think about the pairs that we can take out, since we're finding square root, you've got the 7s, the 2s, the 3s, and the 12s. So our final answer, or close to our final answer, would be 35 root 2, because the 7 combines with the 5 out there. Then you have 6 root 3, and then minus 12 root 2. And the only ones that are going to combine now are going to be my 35 and my minus 12. So my final answer would end up being 23 root 2 plus 6 root 3. So now the next one, if we look at number 4, which somehow has all these drawings in it, but I'm just going to rewrite it. So it's a square root of x squared to the 5th, root 5 to the 9. Now if you remember which one's your index and which one's your power, my 5 here is going to be my index. That's what tells us what root to take. Our 2 here is our power, and if you remember powerful people on top, so power over index, I'm going to have x2 over 5 raised to the 9. And the way that exponent rules work, if we have a power raised to another power, we're going to multiply those. So 2 times my 9, my final answer would be x to the 18 over 5. And we can't simplify 18 over 5. Moving right along, it's the same type of problem for number 5. My index is going to be 3. My powers are 2 and 5. So if I rewrite this now, I'm going to have y to the 2/3 and then z to the 5/3, all raised to the 4th power. And again, we're going to multiply our powers together. So my final answer would be y to the 8/3 and z to the 20/3. For the next one, number 6, we still have exponent rules. And if you remember, whenever we multiply exponents together, we're going to have to add them. And whenever we divide exponents, we're going to have to subtract them. And so just the way fractions work, we're going to have the same denominator. So if you think about your 3, your 4, and your 8, the common denominator between all of them is going to be 24. And in order to turn those into 24, I'm going to have to multiply, my 2/3 is going to have to be multiplied by 8, because 8 times 3 gives me the 24. My 3/4 is going to have to be multiplied by 6, and my 3/8 down here is going to be multiplied by 3. So let's rewrite this whole equation, and we'll have b to the 16/24 times b to the 18/24 all over b to the 9/24. So if we solve this now, I'm going to add the exponents on top, so I'd end up with b to the 34th over 24, because again we have to add these exponents together, all over b to the 9 over 24. And if we subtract my 34 minus 9, my final answer is going to be b to the 25 over 24. Now what you can also do is go and put in the 2/3 plus 3/4 in your calculator and then minus 3/8 and convert that to a fraction. You'll still get the same answer here. But if we look at number 7, we've got more radicals, so we're going to need to break down our 72 first. So I've got 72, and if we make my factor tree, you've got your pair of 6's that come out of there and the 2 that stays inside. So if we rewrite this equation, or this expression, we've got 6 root 2 over 12, and we can divide both 6 and 12 by 6 now, and it leaves me with 1 over 2, because 6 divided by 12 is 1/2. So we have 1 root 2, or just root 2, over 2. Now the bottom part's where we're solving. If I want to find what this x is, we need to isolate that x. But first, we've got to get rid of this cube root sign. So if you remember the opposite of cube root, we're going to have to cube both sides of my equation. What you do to one side, you always have to do to the other. Now this cube root sign is going to basically undo this cube sign. So these are essentially going to cancel out, and they're both going to disappear. But we still have to do the 2 cubed. So 2 times 2 times 2, I know gives me 8. And then the cube and the cube root undo each other, so it just leaves me with 8x. And on the other side, they undo each other again, so I'm just left with x plus 7. If we take away x from both sides, you've got 7x equals 7, divide by x, and 7x equals 1. That kind of looks like a greater than sign. Divide by 7, and you just have x equals 1. Next one is similar to it, but in this one you're given a rational exponent instead of a radical. So we're going to rewrite this first. So if you remember power over index, my power is 1, my index is 3. So now I have 4, and then the cube root of x minus 6 equals negative 12. And again, we need to isolate our x right there. So I'm going to divide both sides by 4. That leaves me with just the cube root of x minus 6 equals negative 3. And remember, if we want to undo this cube root sign, we're going to need to cube the whole side, just like we did on the problem before this. And we cube the other side. So now I'm just left with x minus 6 equals negative 27. We can add 6 to both sides and get x equals negative 21 for our answer. Now go ahead and flip the page, look at number 9. Most important part is in the directions here. It says solve for x if f of x is 320. So you know exactly what to swap out for f of x. So we've got 320 equals 5 x to the 1/3. You can do a couple things here first. If you want to divide out the 5 from both sides, we can do that, or you can rewrite this rational sign. But if we do 320 divided by 5, that's going to leave us with 64 equals x to the 1/3, and we're going to need to rewrite this again. So instead of x to the 1/3, you've got the cube root of x. Well, if you want to undo the cube root, we're going to have to cube both sides, and then cube both sides of 64, and it's going to give you a pretty big number here. Your answer is going to be x equals 262,144. Next one, we're solving for x again. So if you remember your order of operations here, or how to solve them, whatever trick you have, I like to go with SADMEG, and it tells you the order that you should solve it in, because we've got subtraction, addition, we've got division, multiplication, if you remember your exponent here, and then grouping, or basically parentheses, radical sign, whatever's left there. So if we think about what's first, subtraction. Well, subtraction and addition, the only thing that's subtracted out of this side is my 8, and since we've got a positive 8, I'm going to move it by subtracting 8 to both sides. So if we subtract 8 from both sides, you see you're left with the 24 on this side, negative 2 times that. Well, the next steps here, we've got division, multiplication. Your negative 2 is being multiplied by this radical term, so let's divide negative 2 from both sides. And now we've got negative 12 equals the square root of x plus 4. Well, we can undo that square root with a squared. We square the other side, you get positive 144 equals x plus 4. Then we can take away 4 from both sides and you get x equals 140 as your final answer. Number 11, the question tells you all the information you need to know here. So we've got the strength S of a 144-inch rectangular beam, so they included that, is related to depth. And if the strength of the beam is 12, so we get 12 units, that's my strength. What must the beam's depth be? So if we solve this, I substitute in my 12 there for the S, and we can do several things. You can divide out the 72 first, but I like to rewrite this because I like to simplify these radicals when I can. So now you've got 12 equals 72, and if we have a radical with a fraction inside, we can put that sign on top and on bottom. And now it should be clear to see that we can simplify the square root of 144 to just 12. So again, the square root of 144 just turned into this 12 here. And now you can do several things again. We can multiply the 12 by both sides. You can do 72 divided by 12, which is what I'll do here. So if I rewrite this now, it turns out to 12 equals 6 times the square root of d, because the 72 divided by 12 gave me my 6. We can divide 6 from both sides and get 2 equals the square root of d. And then square both sides and you get d equals 4 for your answer here. We can always check these answers by plugging them back into our original equation as well. But number 12, net income in thousands of dollars for a seed business is I, so my net income is I, equals this equation here, with n represent the number of seeds. So for A it says how many seeds must they sell to break even. Well, if you think about it, if you have a business, a profit would be if you have positive dollars, and negative would be if you have negative dollars. So breaking even, our equation is going to have to be equal to 0. When we have 0 equals 12.5 times the cube root of n minus 500. The nice thing about having 0 on that side is our first step, if we divide by 12.5, well, 0 divided by 12.5 is still 0, because 0 divided by anything is 0. And so we have 0 equals the cube root of n minus 500. And to undo cube root, if we cube it, again, 0 cubed is still going to be 0, so we just have 0 equals n minus 500, which means n has to be 500. So 500 seeds is what they have to sell to break even. And then B is the exact same question, except instead of breaking even, we're going to solve that with $500,000 on one side. And my steps are still the exact same. We need to divide by the 12.5, divide 500,000 by 12.5, and you get 40,000 equals the cube root of n minus 500. Same step again, we need to cube this right side to undo the cube root. So we need to cube this side, and it's going to give us a pretty big number. So I'm just going to leave it as 40,000 cubed equals n minus 500, and if you move the 500 over, you're going to get a total answer of 40,000 cubed plus 500, which gives you a big number, 6 point whatever raised to the 13th power. But you could always simplify that in your calculator if you need be. Now the next one, it says, are these two functions inverses of each other, and prove it. You can do these two ways. If you like doing it with composition, you can stick with composition. Or if you just like doing it by pick one, you can just choose one of these two and find it for the inverse to see if it matches. So for example, I'll pick f of x and just solve it. So we know our first step, replace f of x with y, and then we're going to switch our y and our x. So if we rewrite this now, I have x equals 2/3 y minus 3, and we just want to solve it for that y now. So I'm going to add 3 to both sides. I get x plus 3 equals 2/3 y, and to undo the 2/3 now, I'm going to need to multiply by the reciprocal, so multiply by 3/2. And if we multiply the other side by 3/2, you get 3/2 times x plus 3 equals y inverse. And so you can distribute this 3/2 out to the x and the 3, or if you just notice it, if this is my inverse, it's not going to look anything close to this because your fractions don't even match up here. So 3/2 x isn't going to be the same thing as 3/5 x. And so that's how we know that they are not inverses, because I just picked one and found the inverse of it and it doesn't match. So for number 14 here, we're going to need to compare the graph of this normal function and its inverse. So first thing, you need to graph 2x plus 1, square root of 2x plus 1 minus 4 on your calculator. And if we graph it, we end up getting the positive side of the square root looks like this, and then remember there's a positive and a negative to every square root, and my negative side would be down there. And the question says, will the graph of the inverse of this be a function? Well, the inverse needs to pass my horizontal line test. So if we do the horizontal line test on this, we can see that everywhere it only intersects my graph one time. So since it only intersects at one time in each of these areas, we can say yes, the graph of the inverse will be a function because it passes my horizontal line test. Now if we want to graph the function and its inverse, the last thing you need to do is find the inverse of f of x here, and you can go through the process of that and you get x plus 4 squared minus 1 divided by 2, and if you put that all in your calculator, you get an inverse over here, and you can always check to see, because they should reflect over y equals x, and both of our graphs reflect, so we can tell we did that one right. And we can also check, and we can tell that's an inverse because it passes my horizontal line, or my vertical line test. Next one, what is the inverse function of x squared plus 1? We do my same steps, so I'm going to swap my x and my y, so I get x equals y squared plus 1. Then I move my 1 to the other side, so I've got x minus 1 equals y squared. And the opposite of something squared would be square root, so if we square both sides, you get y inverse equals the square root of x minus 1. And now it says, is the inverse a function? Well, if you graph this square root function, if we have the positive and negative versions of it, we get something that looks like this. And we know that's going to fail my horizontal or my vertical line test, so we know that the inverse is not a function. If we go down here to the next inverse problem, we still solve it the exact same way. We're going to switch my x and my y first. So I have x equals y squared plus 18y, because we also had to switch with that x there, plus 81. And my two numbers that multiply to give me 81 and add to give me 18 need to be positive 9 and positive 9. So if I rewrite this, now I have x equals y plus 9 times y plus 9, or since we have two of them, we have y plus 9 squared. And the opposite of squared would be square root of both sides, so we have the square root of x equals y plus 9, and then move my 9 to the other side by subtracting it, so you have the inverse equals the square root of x minus 9. And remember, that 9 is on the outside of my radical because we subtracted it afterwards. And of course you would have plus and minus of the square root. Last page, flip it to the back, number 17. Says when the parent function y equals x, and if you remember your parent function y equals x, looks something like that, shifted 1 unit down, so we're taking this point, go 1 unit down, and 2 units to the left. So we went 1 unit down and then we go 2 units to the left. What is the resulting equation? Well, my new graph, since we went 1 unit down, 2 units to the left, we're going to start here now and go, and my equation is going to be the square root of x plus 2, because we went 2 units to the left, and then the 1 unit down just adds a minus 1 to the end. So that would be my answer right there. We have y equals the square root of x plus 2 and then minus 1 at the end. 18 is very similar to that. It says what transformations are occurring on the graph if it is written as this. Well, if you remember your general form, if I have f of x equals a times the square root of x minus h plus k, I have my minus 3 here, and that's my h, and since we have a minus h, my graph is going to go to the right 3. So all you have to write is right 3. And the plus 4 at the end there is my plus k, and I know that that's going to go up 4. The way that I remember these is k is on the outside like the sky, and you have to go up and down to get to the sky. H is on the inside of your house, and in your house you move right and left. I know it's dumb, but it works for me. If it works for you, you can use it. Number 19, parent function, y equals the cube root of x. Now this graph looks a little bit different than our square root because we've got this curvy little s here, and it goes right through the middle, my origin. It says stretch vertically by a factor of 2. So if you imagine you grab each of these ends of the graph and pull it in opposite directions, stretch it vertically, it's going to straighten it out a little bit, reflect over the x-axis. So we know that it's going to flip over my x-axis right here, and then shift it up 5 units. So my whole graph is just going to go up 5 units. And so if we write our new equation, we know that the shift up 5 units is my k value. My stretch vertically is going to be my a value. And then reflect over the x-axis just means I'm going to have a negative a value. So we have our answer if we fill in the a, h, and k's right here. So please, like the bottom of the review says, please study for your test. Do very well on this one. It will be the last grade of the 6 weeks for you.